So my name is McDonald, and I'm going to be leading a hands-on tutorial titled Building an Agent-Based Model AnyLogic. So we're going to use the software called AnyLogic. The free Personal Learning Edition or PLE version is available for download for all the major platforms. So we're going to start this morning from scratch, building up an agent-based SIRS model for livestock. And then we're going to add a representation of antimicrobial resistance to the model. And then, depending on how much time we end up having, we may take a look at examining the stochastics in the model and making the animals actually move visibly on the screen. So since this is a hands-on, if you need me to repeat any instructions, please speak up. I'll ask you to save any other questions till the roundtable as the organizers have asked. So I'm just gonna try to get out of PowerPoint here. And we'll come back to these other slides later. So I'm gonna start. Oops. My Zoom control is getting in the way. I'm going to start by launching AnyLogic PLE. So we'll give that a moment to load. So if you haven't used it before, you should see this screen when it launches. So I'm just going to go to the upper left here where it says welcome, and I'm going to click the X to get rid of the welcome screen. And then we should see something like this. And then I'm going to go to the File menu and choose New and Model. So this will bring up this dialog to create a new model. Look, it's legible. Is it hard to see? Okay, I'll change my screen resolution down, and hopefully that'll help. Oh, is that better, or is it still bad? How about there? I think that's probably as small as I want to make it. So hopefully you can see that. No?
And also the Wi-Fi is connection-free Wi-Fi. So if you can run to that, sorry to interrupt.
Yeah, so I'll just continue. I think you can join the Zoom meeting and view it on your own screen as well as a possible. So I'm going to give this model a name. I'm just going to call it ASAS demo. And an important thing we're going to select at the start when we create the model is the time units. So it says model time units here, and the default is seconds, but I'm going to change that to days. Okay, sorry. Okay. All right, we're just having another technical difficulty here. All right. So I gave the model a name. I changed the model time units to days. And I'm going to click Finish. And it's going to create the new model. So we should see something like this on our screens. So there's two kind of main tabs on the left here. There's the projects and the palette. And in the center, we have the canvas, which is currently showing main, which is the main part of any model you make in the software. And then there's a properties dialog, which changes depending on what we have selected. What is that? Oh. Are we good?
Keep going.
Okay, thank you. So I'm going to go to this palette on the left, and you may have to click on it to bring it into focus. And then I'm going to go to, there's one called presentation, which has a few geometric shapes on it. I'm going to drag a rectangle into main in the canvas area. And that's going to create a rectangle, and I want to put it at the origin of the coordinate system. So now we see, zoom. Okay, sorry about that. We see the properties for the rectangle, and I'm going to make sure the X and Y are 0, and then I'm going to set the width to 500 and the height to 500. And that's going to make it quite big and fill most of what you can see on the canvas. And that's going to set up our main area for the moment. The next step I'm going to take is I'm going to go to File, New, Agent Type. I'm going to create a new agent type. And that should show a dialog like this. I'm going to name the agent CAF. And then I'm not going to change any of the other options, and I'm going to click on Finish. So now we have a CAF canvas in addition to main. And CAF should come into focus because it's new. And then what we're going to do is we're going to take, we're going to go to the palette presentation if we're not already there, and we're going to drag an oval in. And I'm just going to scroll the view a bit here into the CAF, not the main. And then I want to reduce the size. So if I hold the control key, it should reduce it in a centered way. And I just made it a little bit smaller there by dragging the handles on it, which are similar to what you might see in any kind of draw program. We're now going to change a few of the properties. So to do that, we need to set up some variables. So I want to go to the palette, sorry, and now the agent section, and there's an orange circle called a variable. I'm going to drag that in. I'm going to call it line color. So it has to be all one word. It has to be a valid Java identifier, and there's certain rules about some characters you can't use. And you'll see an X show up in red if you name it in a way that it doesn't like. So with this new variable still selected, I'm going to go into the properties region, and I'm going to change the type of that variable to color. And I'm going to set the default value to, by typing it in, to black. And then I'm going to do a similar thing. I'm going to drag another variable in, and this one is going to be called fill color. And then in its properties, the type,
is going to be color again, and the initial value is going to be white. Next, we want to connect these variables to this oval that we just put in here to represent the visual appearance of the agent. So I'm going to go to the CAF canvas and click on the oval. So we should see in the properties of the oval now. And so we can select these properties through the graphical user interface, but there's this equal sign looking thing here. And if I choose that, we can change it to a dynamic value. So the parallel line should change to a sort of circular arrow, and it should give you a code box that you can type in. So the fill color is going to be fill color, which has to be the name of the variable. And the line color. Now I'm going to show you what is called autocomplete. And this is a very valuable tool for, first of all, if you forget how to spell some command, it shows you the options. But also it really helps guard against making mistakes in spelling. So if you hold down the control key and press space on a PC, or option key and space on a Mac, you should get this menu that lists several things that may match the text you've already typed. So I'm going to choose line color from CAF, which is the first item, by pressing enter. And then it's going to fill in that variable's name. And the last thing I'm going to change in the oval properties is the line width. And we're just going to make it a little bit bigger to 2 points. And we're just going to do that manually. We're not going to link it to a variable. So the next step, I'm going to build the model. So that you can see this icon in the toolbar. It's got 0, 1, 0 and a document shape. I'm going to click on that. That'll build the model. And on mine, it says build completed successfully in the bottom left. But you may get some errors if you made any mistakes following, and then you would have to address those errors. So far mine is good. So I'm going to move on to the next bit. And we're going to drag a state chart entry point. So this is from the palette, the agent section, state chart entry point. I'm going to drag that into the CAF agent canvas. And I'm going to name it infection state chart, again, all one word. So it's important that you don't use the initial state pointer, which looks similar, but is a different thing. So we want the state chart entry. Now I'm going to drag in a state, and I'm going to move it right near the entry point. And I'm going to name this susceptible. And I'm going to make its fill color green. This is in the properties for the susceptible state. And then in the entry action, I'm going to write fill color. I'm going to use autocomplete. Choose fill variable fill color. And I'm going to say equals green. And then a semicolon. It's important that you remember the semicolon. This is Java code for anyone who is familiar with any programming languages. So it requires semicolons at the end of every line that's issuing a command. So we're going to drag another state in, and I'm going to call this infective. I'm going to make the fill color red, and then I'm also going to make the entry action in a similar manner to what we just did. Say fill color equals red semicolon. And then one more time, I'm going to drag another state in. I'm going to call this recovered. I'm going to set its fill color to gray, and then I'm going to say fill color equals gray semicolon in the entry action. So you may wonder, this may seem redundant, like I'm choosing a box that says gray for the fill color, and then I'm putting in this code that says fill color equals gray. So this first box here for fill color sets the color that we see on the screen here. The second one is a command that says set this variable, which is also named fill color, to gray, which we had previously linked to the oval. So what it's telling it to do is we're also going to set that oval's fill color to gray when the animal enters this state. So state charts, this represents 3 mutually exclusive states that the animal can be in, but we also have to have what are called transitions. So I'm going to drag in a transition from the palette in the agent section, and I'm going to connect it between susceptible and infective, and you want to see little green dots where the arrow touches the tail and the head of the arrow touch the states to make sure it's connected as far as the computer is concerned. And then I'm going to bring in another one from infective to recovered in the same way, transition. Next, I'm going to run the model. So beside the build on the toolbar is this green arrow. I'm going to click on that, and we're going to actually see an early version of this model in action. But oh look, it's not doing anything. So we have more to do before it really does anything. We just see an empty pen with no circles for calves anywhere to be seen. So to address that, I'm going to go back to the main canvas this time. So we've been working in the calf. I'm going to go to the main. And I'm going to go in the left pane, I'm going to go to the projects tab. And I'm going to drag calf into main. And that's going to create a population of calves in the main model. And I'm just going to call this animals. And you can drag around the text to make it nicer if you like. And this, we can see, can be a single agent or a population of agents. So we want to make it a population of agents. But we can say 100 as a number for the number of agents, but we want to actually set up something so we can change that if we want to at the experiment level. So I'm going to go back to the palette, the agent section. I'm going to drag in a parameter, and I'm going to name this population size Again, this has to be a valid Java identifier, so it can't have any spaces and certain other special characters. So this is a parameter of a model. It's named population size. We're going to change the type to an int, which stands for integer. And I'm going to set the initial value to 200. So I dragged in a parameter, named it population size. It's a type int, value 200. Now I'm going to click back on my population of animals. And I'm going to go to the initial number of agents area. And right now it says 100. But I'm going to change this to population size. And I'm going to use the autocomplete. And the first option is population size inside of main of type int. So I'm going to hit enter. And that's going to fill in the name population size there. So let's run the model again. So I'm going to click on the green button with the play icon, and we'll run the model. So now we can see our population here. It says there's 200 calves. We have our parameter that says the population size is 200. There's a little, if you look and you can click and drag to scroll the view here, there's apparently one calf in the upper left corner of the pen. So what's actually happening here is there are 200 of them and they're all stacked up in the same place. So we're going to want to change that now. So I'm going to go to main in the projects tab. And there are a lot of options here. And we're going to look for the one that says space and network. And these can all be folded up. So you might have to click on the name space and network to actually see the details. And we're going to choose the layout type to be random. And the network type is going to be distance based. And we're going to leave the connection range as the default of 50. So let's run the model again. So now we have animals randomly distributed throughout the pen, but they're all gray, which means they're recovered from the infection. So we're going to have to do some changes to the infection behavior, but to set things up for that, I'm going to bring some more parameters into main. I'm going to go to palette. I'm going to drag a parameter into main. I'm going to name it mean infectious period. So its type is going to be a time. Its unit is going to be days. And its default value is going to be 15. So again, drag the parameter in to main. Named it mean infectious period of type time, unit days, default value 15. And then we're going to do a few more. So I'm going to put in another parameter in main called, and if I can spell correctly, contact rate. And it's going to be a type rate. Its unit is going to be per day. And the default value is going to be 10. And then another parameter I'm going to call infection probability, which is going to be of type double, which is the default, so I don't need to change anything. And the value is going to be 0.05. So double stands for double precision, which is a decimal number. So it can hold any value from a very large negative to anything with many decimal places like 0.00005, or it could be a very large positive number as well. That's to be contrasted with the population size, which is an integer, so that can only be 1, 2, 3, 4, 5, nothing in between. So, one more parameter. Well, more than one actually, but we'll do another one right now. Mean, its name is going to be duration of immunity. I'll just scroll this bit so you can see that. It's also going to be a time, unit, days, and I'm going to say 150. And then another parameter, I'm going to call this connection range. And it's going to be a type double, and the default value is going to be 75. So there's a bunch of parameters. Now we have to connect them to different features in the model. So if I go to the projects tab and select main in the leftmost pane, I want to go back to the space and network area in main's properties. So before we had the connection range set to a fixed value of 50. Now I want to point it at our connection range parameter. So I'm going to start typing connection range. I'm going to control space or option space, depending on your platform. And then the first option is the one we want, so I'm going to hit enter. So now it should say connection range equals connection range. Now we need to change some things in the CAF. So in the center pane, I'm going to click on the CAF tab. And we'll come back here. So this transition from infected to recovered, I'm going to click on that to select it. And it should have an auto-generated name like transition 1. Won't worry about that. I'm going to change its trigger to a rate. And then I'm going to change the rate to 1.0 / main dot mean, and then I'm going to use autocomplete. And we want to select mean infectious period, which on mine is the second choice. So I'm going to just going to show that code a bit bigger in case anyone missed it. So it's 1.0 over main dot mean infectious period, because that parameter mean infectious period lives inside main. So we have to tell it go to main and then find this thing in main called mean infectious period. That's what the dot tells us. We'll just adjust my window again. So infective to recovered, we made that change. Now I'm going to go into the palette, the agent section again, and I'm going to pull in a transition, and it's going to go from recovered to susceptible, and that looks kind of messy. I can add extra points into these arrows by double clicking on the line. and then dragging the point to where I want it to make it look a little bit tidier. So we've got now a transition from recovered back to susceptible. Oh, sorry, I'm getting ahead of myself, but we'll finish this step. So this should also be a rate, and it should be 1.0. Oops, I'm getting this again. 1.0 over main dot duration of immunity. And then I'll use the autocomplete. So this is on transition from recovered to susceptible. It's 1.0 over main dot mean duration of immunity, which was the parameter we created earlier. So that was, I kind of skipped ahead because I was not following my notes carefully enough. But what we also want to do is we want to bring in another transition, and this is going to be what did we call an internal transition to effective. So I'm going to take an arrow, and it's going to go from one side of infective to the other. And its trigger is going to be a rate. And that rate is going to be main dot contact rate and now for the more ugly part, we're going to have to put some more complex code in the action. So I'll type this code out, and then I will show it large so you can, if you miss it, you can copy it down. So I'm going to say if, and then I'm going to open a round bracket, and then I'm going to have main dot infection probability. And then I'm going to go outside of the round bracket, and I'm going to open a curly bracket. And then I'm going to indent with tabs. And I'm going to say deliver to, and there's going to be several options for deliver to. We want deliver to random connected. So I used the autocomplete there to get that menu. And then, so it's going to say deliver to random connected message. And our message, we're going to replace that with exposure in double quotes. And then I have to make another line, and I'm going to close the curly bracket. So just zoom this up. Hopefully you can read that on the screen. So it's if round bracket main dot infection probability, close round bracket, open a curly bracket, and then on the next line, deliver to random connected, open round bracket, open double quote, exposure, close double quote, close the round bracket, semicolon, new line, close the curly brace. Okay. So I hope everyone's managing to follow along. I know this is a lot of stuff, but our model is going to start doing something interesting in a moment. So I'm now going to go to inside the CAF canvas. I'm going to select the transition from susceptible to infected. And we're going to make a change here. So right now it's a timeout trigger. We want to change it to a message. We're going to leave the message as type object for now. And then we're going to say unconditional. So let's run the model. Ooh, I've got errors. So let's see. I'm going to cancel and see what. Now, here I made a mistake. And that's on me because I wasn't reading my notes well. So this says type mismatch cannot convert from double to Boolean. So I gave if, and then I gave it a probability. But the if then else structure for anyone who's done any kind of programming needs a true or false, right? So what we actually, I missed a piece in here, which is called random true. So I'll show this code big again. So I'm going to need another opening and another closing round in there. So let's make this big so everyone can see. So the correct code is if random true, open round bracket, main dot infection probability, close round bracket, and then close the other round bracket. So what this is going to do is with a probability of infection probability, it's going to return the value true, otherwise false, and then that's going to govern the if function. So let's make that correction, and we'll try running our model again. And now mine is working, and look at this, everyone's susceptible. Why do you think that is? Anyone want to shout out a thought? We haven't introduced a pathogen, right? So how do we do that in the model? I'm going to show you in a moment. So I'm going to close the running model and go back to the main canvas. We want to look at main's properties, and we're going to have to put a bit more code in the on starting section. So this is going to be deliver to, and there's several options again when I autocomplete, but the one we want is deliver to random agent inside. So those calves are inside of main. We want to tell a random agent inside of main to get an exposure. So this should look like this: deliver to random agent inside, in double quotes, exposure. Well, let's try running it one more time. Oh, look, we've got a couple infective animals. Some have recovered now, and the infection is spreading among the susceptibles. So there we go. We've now got a functioning infection model after all of that sort of boring cleanup work. So now we can do some things with this. So what I'm going to do is I'm going to go to the main canvas. I'm going to click on the animals population, and we're going to introduce some statistics, which we're then going to use to draw some plots. So there's a statistics section of the properties of the population. And right now it's empty, but we can click the plus to add a statistic. And this user interface looks pretty ugly, but I'm going to give it the name susceptible. And again, this has to be a valid Java identifier. It's going to be a count. And the condition is going to be item dot in state. So again, remember, autocomplete is your friend, control space, option space. So in state, And then state is going to be the state of the calf. So we're going to say capital C calf dot susceptible. And again, we can use autocomplete to fill that in. So this is going to give us a count of the calves that are in the susceptible state. And then we're going to do some similar ones. Oh, and I've destroyed my code. So I'm going to type that back in. So item in state calf dot, oops, got to spell it correctly, otherwise the autocomplete doesn't like it. Calf dot susceptible. All right, I'm just going to click in the name because I know that'll force it to save that code. That's kind of obnoxious bug. Anyway, so we're going to make another statistic. We're going to call this effective. It's again going to be a count, and it's going to be, its condition is going to be item dot in state calf dot effective, and remember you can autocomplete. And I'm going to click in the name with malice aforethought and that to save that code, and then I'm going to make another statistic, and this is going to be called recovered. It's going to be a count, and its condition is going to be item dot in state calf dot recovered. So good, we have some statistics. Now we want to actually, we could view these numerically, but we would like to, or at least I would like to view them as a graph, because that's, in my opinion, easier to interpret. So we're going to go to the palette here. We want to make sure we're on the main canvas in the center. And then we're going to go to the palette, and we're going to go to a new section that we haven't used before called analysis. And I'm going to look for a thing called a time plot in the analysis section. And I'm going to drag that into the main canvas. And I'm going to make it a bit bigger. So now we have a graph, but we have to tell it what to put in the graph. So we're going to look at the properties of this time plot. And there's a section for data right near the top. And it should have a placeholder for one data set already. So I'm going to change the name of the placeholder data set to say susceptible. Now this title is a friendly title, not a Java identifier, so you can use spaces and special characters if you want to. The value is going to be animals, which is, remember, was the population of calves was named animals dot susceptible, and it's going to put in a round, unopen and close round bracket, because that's the way the Java treats that statistic as a function. And just to be consistent with our color, our susceptible is going to be green, and we'll leave the other settings default. I'm now going to add another. The title will be infective. The value will be animals dot infective. And the color can be red to be consistent with my other usage. And then one more, I'm sure you can guess what it's going to be. Called recovered. The value is going to be animals dot recovered. And again, I'm going to make the color gray to be consistent with the other ones. So there's some other options we want to change on this plot before we're ready to run the model again. So there's a data update selection. It should default to update data automatically, which is what we want. Starting at 0 days, which is what we want, and recurring once a day. And then I'm going to go here. It says display up to 100 latest samples. I'm going to put this to 10,000. I tend to put it to an arbitrarily large number, but not an extreme one. So if you put in 1 billion, you might find the model is very slow. But I'm going to plan to run this model a year or maybe a few years. So 10,000 days is more than we'll need, but not ridiculous. Now we're going to look at the scale section. And I'm going to make the time window for the scale 365 model time units. And then I think that's it for this. So 365 model time units, which were days, as we said at the beginning. So let's run the model. So I'm gonna, at the bottom, we have some controls for the speed. So by default, it's a relative scale of 1. I'm gonna click the plus to speed it up a bit. And we can see our graph filling up. Susceptibles decline, infectives reach a peak and then decline, recovereds increase. All right. So I just want to demonstrate something else. What if I run it again? We might notice something, or you might not. You might notice the graph looks the same. Sorry, is there a question?
Excellent, great. But how? What is the data? What is the link of the data? The real data that is generated.
So we don't get to that in this demo. But what we can do, you talked about calibrations in your talk, right? We can take, we now have what the model thinks the susceptible, infective, and recovered are over time. If we have measurements of the true state of those in a group of animals, we can then adjust the model's behavior by changing parameters so that the graph best approximates the real world data. Does that answer your question?
But still, in order that you do this course and all that, there is some data behind it. I miss where did you link to some database that is making it happen?
Okay, it's not coming from a database, actually. And some modeling people are fond of the saying structure determines behavior. So the things that are determining this behavior, we've set some parameters here for the way the disease behaves: mean infectious period, contact rate, probability of infection, and duration of immunity. And then we further set some structure for how an animal can be infected. It can only become infective if it's insusceptible and is exposed by an infective that's near it. So this structure, even without binding it to a database, is determining the shape of those graphs because it can only behave in certain ways based on the structure we've defined. Is that helpful? So this is the end of my first section of the demo. And we seem to be reasonably on time. We've got about half an hour left. So I promised to add an antimicrobial resistance feature to this. So let's go on and move that. But before we do that, I want to make one more change. So in the projects tab, the simulation, I can't remember if I'm getting ahead of myself on this or not, but I want to go to the model time and tell it to stop after a year. So I'm going to stop at, this is in the properties of the simulation. Model time, stop at a specified time, not date. And I'm going to say 365 days. And that's just going to make some things easier later on. The other thing I'm going to change is the randomness. So I'm going to change it from a fixed seed, which is the default, to use a random seed. And what this is going to do is it's going to be different every time. So let's just explore that briefly before we move on. So now I can run this really fast and we can see the graph nearly immediately. So we ran it once, we get a certain graph. I'm going to hit the stop button and then the play button, and then we get a different graph because this is a consequence of the way computers create random numbers. But by using a random seed, we get different behavior every time from the random components of the model. All right, so we're going to do some more kind of housekeeping tasks here. So if we go in the projects tab, I'm going to right click on the outermost level, which is the model, and then choose new, and I'm going to create something called an option list. And I'm going to get this dialog. I'm going to name my option list message types. I'm going to click finish. And then it should be selected by default, and we can add in some values for this, and we're going to call it exposure for one. And then we're going to say resistant exposure as another one. And now we're going to go to the calf canvas. And we're going to come here to this transition from susceptible to infective. So previously we said it could be any object for the message. But now we have this option list. I'm going to say it has to be a message type message. So, but we're still going to leave it as unconditional. So if it gets a regular or a resistant exposure and it's in the susceptible state, it's going to move to the infective state. Now we're going to add a second state chart into the calf. So I want to go to the palette, the agent section, And I'm going to bring in a new state chart entry point. Remember, don't confuse it with the go away tooltip, the initial state pointer. We don't want that. State chart entry point is what we want. I'm going to bring that in there. I'm going to call it the microbiome state chart. And then I'm going to drag a branch in, and we haven't used this before, but a branch is this diamond icon in the state chart building blocks. And I'm going to connect that to the entry point. And that's going to represent a decision point in the state chart. Now I'm going to drag a state in, and I'm going to name that state not resistant. And I'm going to make its display color white, and its entry action is going to be line color. So if you remember earlier, we set the fill color of the icon. Now we're setting the line color based on resistance. So it's going to be black, and it's a command, so we need that semicolon at the end. So new state named not resistance, fill color was white, entry action line color equals black. And then another state, I'm just going to be calling this resistant. I'm going to make it magenta. And the entry action is going to say line color equals magenta, semicolon. Now we need a transition, so I'm going to drag a transition in, and we're going to connect not resistant to resistant. And we're going to say this transition is going to be triggered by a message. The message type is going to be our option list message types. And then it's going to be on a particular message. And the message is going to be, oops, I need to spell it correctly, RE, resistant exposure. Now, we don't want, in this example, I only want them to acquire resistance if they acquire an infection. So I'm going to put what is called a guard on this transition, and it's going to say in state and this is going to be susceptible. So we'll zoom in on this code. So the message was resistant exposure, but it has a guard that says in state susceptible. That, well, it's not showing up on the big screen. I'm sorry. I'm not going to troubleshoot it now. All right. There we go. So now we have to change another few things. I think I'm missing something here. So we need a transition from the branch to not resistant. And this transition will have different options. It could be conditional or it could be default. And we want this to be default. So I missed that step. I drag a transition in, connect the branch, which is the diamond, to not resistant. Default condition. Now we're going to go to main. And then we're going to make a bit of a change to this on startup code because we changed our message to use that option list. So this, instead of exposure in quotes, this is going to be message types, and there might be a lot of, so we want the message type that belongs to our model. There's tons of things with the words message in it. So message types dot exposure. So that's changed. And then we're going to go now again to the calf. And we're going to go over to the infection state chart and look at this internal transition on infective. And we're going to put in some more complex code here. So we have if random true main infection probability, that's fine. I'm just going to clear out the line that's in there, and then I'm going to put in another if inside the curly brackets that's going to say in state resistant. No, wrong one. So you got to watch with autocomplete sometimes if you choose the wrong one. Now, why isn't it? We want in-state resistance like that. And I don't know why the autocomplete isn't working for me, but hopefully we don't have to troubleshoot it live. So another if condition, in-state resistant, then we're going to say deliver to random connected, and this message now is going to be message types dot resistant exposure if it's resistant. Then outside of one of the curly braces, I'm going to put an else, and I'm going to have another pair of curlies, and this is going to say deliver to random connected message types. I got to watch my typing here. Dot exposure. So if this calf is resistant, it's going to expose others with the resistant pathogen. If it's not resistant, it's just going to regular expose them. So a couple more housekeeping things, and then we can run this. So I'm going to go to main. I'm going to look for my animals population. And we're going to go to statistics as we did before. I'm going to add another statistic. And this one is going to have the name resistant. Its condition is going to be item dot in state calf dot resistant. Let's see, it's not happy. So I'll just type it in the old fashioned way. I'm going to build my model because and it seems to be happy with that. Okay. Sometimes when the autocomplete is being weird, it means there's an error somewhere in the model, but it looks like it's happening. We're getting close here. So we're going to bring in another graph. So I'm just going to scroll my view over here. So to do that, again, we went to analysis in the palette. And then we brought in a time plot. So I'm going to bring in a second time plot. Expand it a little bit. And then we're going to look at the properties of the time plot. Most stuff is going to be default. I'm going to call this resistant, the first data set. Its value is going to be animals dot resistant, and it's going to be a magenta color to be consistent. And then most of this is going to remain default. I'm going to display up to 10,000 like I did before. And then in the scale, I'm going to say 365 model time units. So let's run. So we have our infection spreading. What don't we see? There's nobody's resistant, right? So we didn't tell anyone to start as resistant, so the resistance can't spread from anywhere. So I'm mindful of the time, but we're closing in on the result here. So I'm going to go back to the calf. And we're going to put in another transition here. So we're going to go to the palette, agent. I'm going to drag a transition in, and it's going to go from the branch to resistant. And I'm going to put in a couple extra points to make it look tidy. And this one is not going to be a default. It's going to be a conditional. And I'm just going to say random true 0.2. So we're going to start with 20% of our animals with the resistant trait. There are other ways to do this, but in interest of time, let's just run it. Now we see some of the animals have a pink or magenta outline. And as the infection spreads, we're also seeing resistance spread from the resistant animals as they spread it to the susceptibles. And we can run and we can see how much resistance spreads through the population. We can see are susceptible, infective, and recovered. So here we have a very rudimentary but a functioning model with an infection and a resistance trait being spread along with that infection under the right conditions.